Okay, hi everybody. We're back for this second video. I'm gonna see if it works out okay to film me as I talk to you, just to make it maybe a little more personal of an experience. Again, I wish we could be doing this in class, but let's make the best of it. So if you remember, um, we were talking about life history models and resource congruence and capacitance. Congruence being those species that use a resource right when it's available. Congruence, having them happen together. Versus, and that was like the Fort Collins shortgrass steppe. There are these grass species that utilize the water in the early spring when it's available, and they go through their whole life cycle. They grow, they produce seed, they let those seeds go when that water is available, so that by the time that water is not available and evaporation is really high, they don't need that water. They aren't limited by that lack of water. And we can compare that then with cacti in the desert that rather than utilizing resource congruence, they utilize resource capacitance. So they soak up that water when it's available and they just hold on to it until they need it later on. So now let's move then into the allocation of captured resources. So now we're thinking about once these plants have actually captured their resources, what do they do with it? Plants have lots of different parts that they could allocate those resources to. And so the roots, the leaves, flowers, reproductive strategies. So plants must operate as this balanced system and maximize their fitness by allocating these limiting resources. And you can imagine these allocation strategies are under strong evolutionary control. So let's think about two different plants, the same species, but two different individuals. One maximizes resources to its roots, one maximizes resources to its leaves. Under different conditions within that year or across years, one of those individuals might produce more seeds than the other. Maybe it was more beneficial to allocate resources to the roots so that it could take up more water and nutrients. Maybe it was more beneficial to allocate resources to the leaves to soak up more sunlight, whatever's kind of more limiting. And these differences in allocation strategies in plants have really been extensively studied. We know a lot about it. And often the question is, what is the most important resource for plants? So think about that. What is the most important resource for plants? The answer is similar to lots of answers in science, is that it depends. Plants allocate resources to roots to acquire nutrients and water, and to shoots to acquire light and CO2. And it really just depends on which one of those is most limiting. They can allocate resources to storage, reproduction, defense, seed production, all of these different ways. And so it kind of just depends on what that most important resource is for what the plant really needs in that moment. So for instance, plants vary enormously in the timing and frequency of their reproductive episodes, and also in the number, size, and quality of the progeny. So some plant species produce a gajillion seeds, and a lot of those seeds aren't even viable, wouldn't even turn into a plant if the conditions were perfect. But they produced a gajillion of them, so it doesn't really matter. Compared to a huge tree that we see in this image, it doesn't actually produce seeds even every year. It produces big, big, giant seeds, and every single one of those seeds is probably viable if it lands in the right spot. And this then leads us to the idea of allocation and plasticity. So allocation is the ability of a plant to send nutrients or resources to different parts of itself, and plasticity is the ability of a species to adapt to changing conditions. So variable early seral environments will select often for species that can quickly shift their allocation of resources. These plants are able to compensate for their resource limitation by quickly changing the allocation to organs or functions that most directly relates to improving the uptake of their most limiting resource. What does this mean? This means that the plants that can quickly shift towards growing new roots if water is limited are going to be preferable to organisms that are slower to reallocate resources to those roots. So if a plant can respond to those new, novel, changing conditions, it's going to be better off. That kind of makes sense intuitively. This reminds me of an experiment that in botany, when I was in college, we had this, semester long kind of experiment, and we put these various plants. I think we were testing for different nutrients. So we were thinking about resources, but it was specifically in terms of nutrients. And we were supposed to put these different quantities of nutrients into these different jars and then look at the plant growth over the semester. And at the end of the semester, we all went in and we took the plants out of these jars. And I remember one kid who sort of sheepishly admitted that he didn't actually ever, over the course of the whole semester, come in and add more water to his jar. These plants weren't growing in soil, they were just growing in jars with water. And I remember taking my plant out, and it was big and robust and leafy, but it had the most spindly tiny roots. And I remember his above the lid, his plant was really, really tiny, and everybody was giving him a hard time, like, oh, your plant didn't even grow, like, I'm surprised it stayed alive. And then he pulled his plant out, and its root structure took up it was still in the shape of the jar. There were so many roots. And it was really eye-opening to realize, like, of course my plants had tiny roots. I was really diligent about going in and adding more water. So why would that plant allocate resources to root growth when it was getting all the water it needed? So it was more beneficial for that plant to maximize the allocation of resources to its leaf and flower development. Versus his, it was more thinking about it in terms of a disturbed environment. His was very water limited and harsh. It was not beneficial for that plant to invest in the leaves. So instead, having being plastic and having that plasticity, it reallocated resources to its roots. For a long time, ecologists have focused on plant response to just single factors. What if we change water? What if we change light? What if we change CO2? But we now recognize that that's a kind of a limited view on plasticity in plant allocation and reallocation. In reality, plants can actually adjust the level of uptake of all their critical resources, such that no one resource is more limiting than the others. And that's pretty cool. And finally, if we think about this phytocentric view of succession, what that means, phyto being plant-centric, so focused, centered, so plant-focused view of succession, there can be winners and losers in the competitive interactions between individuals, right? Like if one plant shades out another plant, that is a competitive winner. But in succession, because we're thinking about succession over long periods of time, there really are no consistent winning and losing species as long as each species completes its life cycle and disperses its propagules, disperses its seeds. And it's important to remember that what it takes, the length of time that takes, is different for each species. So this can be one single season for an early cereal species. If it can last and produce seed in that one season, it's won the successional game. It has completed its life cycle and produced seed. But it might be centuries, right, for a late successional tree like this giant sequoia. It takes a long time for that tree to mature and produce seeds. So its ability to be a winner in succession takes hundreds and hundreds of years. So when we think about winners and losers of succession and shifting competitive dynamics, always keep in mind the temporal nature of what it takes for a plant to be successful really just means what it takes for a plant to produce seed and get that seed out. Anyway, that's it for this week. You've got some other YouTube videos to watch and a reading to do. And feel free, of course, as always, to email me with any questions you have. But I hope you are all healthy and well and staying active and staying healthy and happy. Let me know if I can do anything for you.